Let's see how to write all the terms in the expansion of 2x squared plus 3 raised to the power of 4. Well, just as in our previous tutorials, we can start by comparing what we have here to the left-hand side of our binomial expansions formula. In doing so, we quickly see that the only difference is that we've replaced a by 2x squared, b by 3, and n by 4. So to get started, we can copy the right-hand side of our formula, replacing every a that we see by 2x squared, every b by 3, and every n by 4. In other words, this is equal to the sum from r equals to 0 up to 4 of the binomial coefficient 4r times, in parentheses, 2x squared raised to the power of 4 minus r times 3 raised to the power of r. And writing this sum is as far as our formula will take us. The next thing we need to do is to simplify the expression that I'm underlining in green. And if you've watched my previous tutorials, you'll know that I like to call this T of r, T as in term. This expression is the general term of our expansion, in the sense that every single term we'll write will be made using the expression we just underlined in green. So let's simplify it. I'll start by copying it, T of r, right here. So that's the binomial coefficient 4r times, in parentheses, 2x squared, all of which is being raised to the power of 4 minus r, times 3 raised to the power of r. Now, the key thing we have to focus on here is this middle term in the product. We have 2x squared in parentheses, which is then being raised to the power of 4 minus r. And the important thing to remember here is that this power 4 minus r distributes onto both the 2 as well as the x squared inside these parentheses. In other words, this is equal to the binomial coefficient 4r times 2 raised to the power of 4 minus r times x raised to the power of 2 times 4 minus r. So that's 2 times 4, which is 8, minus 2 times r, which is 2r. And that still multiplies 3 raised to the power of r. Finally, although we don't have to, I always like to make sure that in my expression for the general term, the power of x is what appears to the far right-hand side. In other words, I write T of r equals to the binomial coefficient 4r times 2 raised to the power of 4 minus r times 3 raised to the power of r times x raised to the power of 8 minus 2r. And that's the expression for the general term. Now back to this sum. Since we call this expression T of r, the sum that we have here from r equals to 0 up to 4 can be written as T0 plus T1 plus T2 plus T3 plus T4. And each of these terms, T0, T1, T2, T3, and T4, can be found by replacing every r that we see inside our expression for the general term by its corresponding r value, 0, 1, 2, 3, or 4. Here's how that works. For T0, we replace every r by 0. So that would be the binomial coefficient 4, 0, times 2 raised to the power of 4 minus 0 times 3 raised to the power of 0 times x raised to the power of 8 minus 2 times 0. We add to that T1, for which we replace every single r we see by 1. So that's the binomial coefficient 4, 1 times 2 raised to the power of 4 minus 1 times 3 raised to the power of 1 times x raised to the power of 8 minus 2 times 1. We add to that T2, for which we replace every r we see by 2. So that would be 4, 2 times 2 raised to the power of 4 minus 2 times 3 raised to the power of 2 times x raised to the power of 8 minus 2 times 2. We carry on and add to that T3, for which we replace every r that we see by 3. So that would be the binomial coefficient 4, 3 times 2 raised to the power of 4 minus 3 times 3 raised to the power of 3 times x raised to the power of 8 minus 2 times 3. Finally, we add to that T4, for which we replace every single r that we see by 4. So that would be the binomial coefficient 4, 4 times 2 raised to the power of 4 minus 4 times 3 raised to the power of 4 times x to the power of 8 minus 2 times 4. And at this stage, we have written all of the terms in our expansion. But now we need to simplify each of these as much as possible. And the first thing I like to do is take care of any powers of numbers, so in this case 2 and 3, as well as any powers of x in each of these terms. So let's go ahead. For this first term, we have 2 to the power of 4 minus 0. Well, that's 2 to the power of 4, and that's equal to 16. And that multiplies 3 to the power of 0, which equals to 1. And that multiplies x raised to the power of 8 minus 2 times 0, which is x raised to the power of 8. Looking at the powers in the next term, we have 2 to the power of 4 minus 1, which is 2 to the power of 3, which equals to 8, times 3 raised to the power of 1, which is just 3, times x raised to the power of 8 minus 2 times 1. So that's going to be x raised to the power of 6. We carry on and look at the next term. We have 2 to the power of 4 minus 2, which is 2 squared, and that's 4, times 3 raised to the power of 2, which is 9, times x raised to the power of 8 minus 2 times 2. So that's x raised to the power of 4. We look at the next term. We have 2 raised to the power of 4 minus 3, so that's 2 to the power of 1, which is 2, times 3 raised to the power of 3, and 3 to the power of 3 is 27, and that multiplies x raised to the power of 8 minus 2 times 3, so that's x raised to the power of 2. Finally, in the last term, we have 2 raised to the power of 4 minus 4, which is 2 to the power of 0, which equals to 1, times 3 raised to the power of 4, and 3 to the power of 4 is equal to 81, and that multiplies x raised to the power of 8 minus 2 times 4, so that's x to the power of 0, which is equal to 1. Now that we've calculated all of the powers inside these terms, we need to find the values of each of the binomial coefficients that we have. And for that, we can use the results that we've seen in our previous tutorials. Remember, the first and the last binomial coefficient will always equal to 1. So we can go ahead and say that 4, 0 is 1, and 4, 4 is 1. The second result worth remembering is that the second coefficient as we go from left to right, as well as the second coefficient as we go from right to left, are both equal, and they are both always equal to the power to which we raise the binomial. So in this case, that's 4. So without thinking, we can go ahead and state that 4, 1 equals to 4, and 4, 3 equals to 4. And at this stage, we see that the only coefficient we actually have to calculate is this middle coefficient 4, 2. And to calculate it, we can go ahead and use our binomial coefficient formula. And I'll do that in the lower right-hand corner. The binomial coefficient 4, 2 equals to factorial 4 over factorial 4 minus 2 times factorial 2. That's equal to factorial 4 over factorial 2 times factorial 2. And that's equal to 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. And we quickly see that the 4 cancels out with the two 2's that are being multiplied on the denominator, leaving us with 3 times 2 times 1 over 1, which is equal to 6. And we can now state that this middle binomial coefficient, 4, 2, is 6. And now that we know the values of the binomial coefficients, we can go ahead and state our final answer. Indeed, we can go ahead and write that 2x squared plus 3 raised to the power of 4 is equal to 1 times 16 times 1 times x to the power of 8, which is 16 times x to the power of 8. We add to that 4 times 8 times 3 times x to the power of 6. And since 4 times 8 times 3 is 96, that's 96 x to the power of 6. We add to that 6 times 4 times 9 times x to the power of 4. Now 6 times 4 is 24 times 9 is 216. So that's 216 x to the power of 4. We add on to that 4 times 2 times 27 times x to the power of 2. Now 4 times 2 is 8, times 27 is 216. So that's 216 x squared. And finally, we add on to that the last term, which is 1 times 1 times 81 times 1. So that's 81. And we're done. We've written all of the terms in the expansion of 2x squared plus 3 raised to the power of 4 using the binomial expansions formula. In our next tutorial, we work through another example in which the x inside our binomial is written on a fractions denominator. So make sure to watch it to learn how to deal with that. For now, though, that's it for this tutorial.